name is Nitish, Mechanical Department from BSc College of Technology. Today I am going to explain selective laser sintering (SLS), one of the most powerful and widely used 3D printing method in additive manufacturing. We will cover how the process works, the material used, its advantages, and how building time is affected by layer thickness. How SLS works? SLS is a powder bed fusion process. It starts by spending a very thin layer of thermoplastic powder, usually nylon, across a flat built platform. Then a high powdered laser scans across the surface of the powder, heating it just enough so that the particles fuse together, a process called sintering. Once a layer is finished, the platform lowers slightly and another layer of powder is added. This process repeats layer by layer until the part is built. The unsintered powder surrounded the part provides support so that no feed for external structures. Material used. The most common used SLS materials are nylon-based polymers, especially nylon 12 and nylon 11. These materials are chosen because they offer high mechanical strength, flexibility, and chemical resistance. For parts that require added stiffness, glass-filled or carbon-filled nylon can be used. For flexible parts, materials like TPU, thermoplastic polyethylene are ideals. These materials choices make SLS very suitable for functional parts and prototypes. Advantages and applications. SLS has many key advantages. It does not need support structures which simplify designs and save time. It produces strong, durable and high functional parts. It allows for complex geometric and detailed internal structures. SLS is used in many industrial includes aerospace, for lightweight brackets and fixtures, automotive, for custom housing and gears, healthcare, for medical devices and prosthetics, consumer products, for IVS, electronics and tools. These applications show how versatile and scalable SLS can be. Now let me explain graph between build time versus layer thickness. One of the important factors in SLS is layer thickness, which is directly of a build time. Here is a clear, well organized list of pros and cons of selective laser sintering. Pros of SLS. Non-supportive structure needed. Let me explain cons of SLS. High machine and material cost. Equipment is expensive, often used only in industrial setting. Rough surface finish. Part often requires post-process like sanding and polishing. Slow cooling time. Let me explain cons of SLS. High machine and material cost. Equipment is expensive, often used only in industrial setting. Rough surface finish. Part often requires post-process like sanding and polishing. Slow cooling time. Part must be cooled gradually in powder bed to prevent deformation. Health and safety concern. Fine powder handling requires proper safety equipment and dust control. Limited color option. Most powder are white or grey. Coloring requires dyeing after printing. Energy intensive process. High powered lasers and heat consume more energy compared to some other methods.